Genda kunyuka ensi njagala omanye ekyowe kyajja naye nga olitwala ki ekikuleetera okukyawa n'oyuzaawo oluganda. Wajja bwerere ebikukyayisa abalala bikyamu. Guma olyekaako muleke alyeka n'ogwo gwe mukwano. Mwana wa taata temulira kyobuna musaayi. Ekyo kikoli mu s5-s funa nakanga katona sika kinene kyaki. Agamaso kanulira bwerere wajja bwerere okayanira bwerere. Ebikumala muteri kyewajja nakyo kimanye kiyoleka emirerembe. Wajja bwerere oddayo oli mwerere. Ebyo byokuma abagabane ku bwerere. Duniya ya Mukama tuli mu kubwerere. Era tetemera bwerere. Agamaso kanulira bwerere wajja bwerere okayanira bwerere. Ebikumala muteri kyewajja nakyo kimanye kiyoleka emirerembe. Wajja bwerere oddayo oli mwerere. Ebyo byokuma abagabane ku bwerere. Duniya ya Mukama tuli mu kubwerere. Era tetemera bwerere.
Welcome to yet another edition of OS e-learning platform. I hope this tutorial finds you well, and before we embark on any discussion today, allow us thank God for the gift of life. Father in heaven, we thank you for the gift of life, and we ask you to bless us, ask you to forgive us, and grant us the grace to forgive those who trespass against us. Give us to appreciate, give us the mercy, the spirit, and the heart that appreciates what you bless us with. Give us the wisdom, knowledge, and understanding to excel in this life. And in particular for the mathematics tutorial today, give us the insight to understand today's lesson. Thank you, Jesus. All this we pray, living through your name, or the Son who lives and reigns within the unity of Holy Spirit, one God, forever and ever. Amen. Students, welcome to yet another edition of Principal Mathematics 425/1, and particular for students in classes Senior 5 and Senior 6, taking Principal Mathematics as part of their subject in the combination. So the subject you have, I'm pretty sure, if mathematics is attached to it, then you are in the right podium, and I welcome you to share with me. So without wasting any microsecond, the topic is actually trigonometry, and the topic is going to help us cover something from a request, and this request is from Tambwe Daniel. He said, "Teacher, I did very many questions of trigonometry. I almost finished the book, but there are some simple numbers I got that I felt like I should share with you." Then I was like, "It is okay, Daniel, it is very okay. Can you please send that work and we see." So I decided to maintain our slogan, love is sharing and giving, and so for that we have to share this as OS team. So the question is, if A, B, and C are angles of a triangle, prove the following identities. 1. Sine A plus sine into B minus C is equal to 2 sine B sine cos B, cos C. Cos A minus cos into B minus C is equal to negative 2 cos B cos C. Sine A plus sine B plus sine C is equal to 4 cos a half A, cos a half B, cos a half C. Then lastly, tan A plus tan B plus tan C is equal to tan A plus tan B. I beg your pardon, tan A plus tan B plus tan C is equal to tan A tan B tan C. So he said, "Teacher, these are simple numbers that I feel we should share." Then I was like, okay, if that is the case, then we shall share them. Then I will also give you an activity at the end of this very tutorial. So I want you to pay maximum attention as we discuss, and also project your opinion in the next activity I will give you that activity. Pause the video, play it, try it out, and check. The answers are within the context, or the responses are within. Because if I tell you prove that this is equal to that, then it means that the answer is already there. So it is upon you to play with the identities. Now let me highlight about two things here. Trigonometry has very many identities that you just need to put at your fingertips. Not even cramming, but you just need to understand them. Two, we apply these identities to prove, solve equations here and there as far as trigonometry is concerned. Now, on this context where we have A, B, and C as angles of a triangle, you should know that the summation of interior angles of a triangle add up to what? The summation gets to 180 degrees. So that should be at your fingertips as you're working with these trigonometric identities. Now let's get into the response. The expected responses I have for number one, after identifying that they want me to prove that sine A plus sine into B minus C is equal to 2 sine B cos C, what I need to do is to pick any side, given the fact that it's a proof, it is a mere proof. But if it is a show that, then you must strictly stand with the left hand side. If I'm talking about the left hand side, this is what I'm meaning. You should start with this side moving towards that. So you start with this side and your final response should be of that caliber. So if it is a show, that is the command, and if it is a proof, you start with any side. So how do you identify the side to start with if it is a proof? It is always the side with immediate possibilities. If you look at the left hand side, it is quite very convenient for us to start with identity of factor formula than starting it with this side. Well, you can still play with that factor formula, but it's going to be quite tricky, and at the end of the day you might consume a lot of time proving it. Well, it comes out, but it takes a lot of time. We find that some perimeters are quite hidden, that you need to think outside the box. Now what we shall do is, since it is a proof, I'm still starting with my left hand side, and the left hand side is basically treating the sine A plus sine into B minus C. Now this is factor formula. How do you realize sine plus sine irrespective of the angles? Sine plus sine plus sine plus sine, that is factor formula. At some point you have to apply that one. 2 sine minus sine minus sine, as long as it's sine, factor formula. So you need to memorize the 4. Cos, that's a cos plus cos, cos minus cos, as long as it is within cos plus cos. Because students sometimes misinterpret this with sine plus cos, whereby that is actually error formula. At some point you have to play with error formula. And I told you we have very many identities in this context, and to mention them, we have error formula, we have t formula, we have factor formula, etc. And we have to break each at a time. So we shall go through them until we get done with them. So when I'm applying factor formula on the left hand side, I will just have a 2 into, I add the angles, a plus a bracket of b minus c over 2, then cos, because it is a plus of sine, so I start with the sine, cos. So sine dominates the position of the starting point, then followed by a cos. Then if it is a minus, then it is a cos that dominates. Then for cos plus cos, it is a cos. Then if it is cos minus cos, then that will be a negative 2. Of course, you should not forget the 2 always. On every factor formula you're expanding. So that will be a 2 sine, 2 cos 2. So I have to maintain that. And for this I will just add the angles. That is a plus b and also minus c, because in the second angle is b minus c. Then in the next case, I will be subtracting the 2 angles. So I subtract b minus c from a. So if I have a, that angle, then minus into bracket, the second angle is b minus c. So you can see that when I open this bracket, b will be a negative, but a c will be a positive. So that's why you're saying that my whole thing goes to a minus b plus a c over 2. So that is the first step of doing the proof. The next step, I will simplify this by first borrowing the identity they gave us in the question, that A, B, and C are angles of a triangle, meaning when I add them, I get a lot of 180 degrees. Now I want to play some logic here by actually looking at what I'm proving and the level I've reached so far. Now when you look at this level, I have A plus B, of which I can get it from this very identity, meaning if I want to remain with A plus B this side, so my C should cross equal sign, and that's why I'm having something of that caliber. So where I have A plus B, I will substitute the whole of 180 minus C. Then why am I doing this? Because I want to make A disappear. I don't have an A in my proof. And also here, the only way I can play with this A to disappear is by making it a subject from the ident of summation of interior angles of a triangle, whereby I have A is equal to 180, then minus B minus C, because all the A and B are crossing, sorry, A, B and C are crossing equal sign, and they are becoming minus B minus C. So where I have A, the whole of this will occupy that position. So that's what I'm doing in the next step. Why am I doing this? Because I want to make A disappear such that I slightly get to my proof. So in the next step, as you can see, I'm substituting that. On simplifying, collecting like terms, what is vanishing is vanishing. Actually, as you can see, minus C and the plus C are vanishing. That's why I'm left with only minus 2b. In the next case, I'm actually dividing that 180 and 2c by 2 by 2. I'm remaining with something of that caliber. In this step now, I need to open the bracket, and that is compound angle. So how do we open bracket of compound angle? Of sine of that bracket, and also cos of that bracket. By the way, we are covering very many things here as far as identities of trig are concerned, and be careful. So when I'm opening sine into 90 minus c, I will start with sine 90 cos c, then minus cos 90 sine c. That bracket is done. The next bracket for cos, I will have cos 90 cos b plus, because here is a minus, plus sine 90 sine b. Now if you get your calc and press sine of 90, you get a 1. Cos of 90 is a 0. So meaning where I have cos, everything is vanishing. So in the first bracket, I'm only left with cos c, and the second bracket, I'm only left with sine b. So that's why the final thing is the product of 2 sine b and also cos c. So therefore, sine a plus sine into b minus c is equal to 2 sine b cos c. So Daniel, I hope we are together now, and everyone who is on this podium today, I hope we're on the same page. Where you're not picking, type it on the comment section. But I've tried to simplify it to the lowest level. We are just using the identities given in the task. So number two, how should we handle number 2? Let's have a look at it. I think we are using the same approach. As you can see, A is actually vanishing in the proof, so we need to look for all possibilities of killing A. So I'm giving you 1, 2, 3, 5 minutes to finish it. So you'll have to pause for 5 minutes and do this. Then you replay the video such that you confirm whether you're right. So anticipating that you're done with the 5 minutes, allow me do it here. So I'm going to take the left hand side because it's a proof. I apply factor formula on the left hand side. And now I will not explain much because now we know how to apply a formula. For cos A minus cos into that angle, since it is a cos minus cos, I will have a negative sign. Sign will dominate. Then the angles added over 2. Then the angle subtracted over 2 for a sign. So the sign will dominate here. It is a sine for cos minus cos. Then if it is a cos plus a cos, that will be cos cos. But a positive 2 cos cos. So here, as I told you that now I have the added angles. I'm just repeating what we had in the previous slide. Substituting, collecting like terms. On collecting like terms, please, the steps are very clear. Very, very clear. I'm trying to eliminate A. And what I'm doing is that where I have A plus B, I can just put 180 minus C. And where I have A, I can put 180 minus B minus C. Collect like terms, I simplify. In the next case here, I'm separating the LCM. 1 over 80 minus 2C divided by 2. It is like having 180 over 2 minus 2C over 2. So that's why it's dropping to 90 minus C, 90 minus B. So I still open here using compounding angles. And on opening, of course, sine is sine, cos, then minus, cos, sine. Then for sine as well, so what I'm left with is getting the calc, pressing the sine of 90 and cos of 90. I confirm vividly that cos 90, sorry, this is a cos. Here must be a cos. Who wrote this one? This must be a cos, please. Don't cause problems here. So this is S. Yes, viewers, be patient. Someone made a mistake here. Okay. So that cos must be a cos. On expanding, pressing on the calc, ideally, I remain with negative cos B. Negative 2 cos B. Cos C. Don't you think we have the answer now? What are you talking about? So basically, we shall conclude by saying, therefore, cos A minus cos into B minus C is equal to negative 2 cos B cos C. As simple as that. I told you the questions are very simple. And the guy said he did everything. Everything is okay. So he just wants to share with us. So allow us share this again. Number 3. Number three. Wow, this is so interesting. I think this is the simplest of all. Yeah, very, very simple. Still, I'm applying factor formula. I'm deciding to take the left-hand side because it is the one that is convenient for me. What are you talking about? However, if you want the right-hand side, I give you a go-ahead. I blow a whistle for you, my brother, my sister, genda maso. So taking the left-hand side, I apply factor formula on one part only. On a pair of sine A plus sine B, don't apply factor formula on everything. So on applying it there, what I will remain with is, of course, add the angle, divide by 2. So since it's a sine plus sine, so that will be 2 sine addition of the angle over 2, cos, difference of the angle over 2, plus sine C. Now from here, to simplify this further, I need to have a substitution for sine C. And that's why I need to recall very many things. So there are things that I want us to first recall. So this is my side work. So they said angle A plus angle B plus angle C, total gets up to 180. We agreed on that. And I'm saying, okay, if I remain with A plus B, is it also the same as 180 minus C? They said very correct. Meaning, if I try to half the angles on both sides, they said it is very correct. And I said, no, I can reduce it in the next case, whereby I separate the LCM on the right-hand side, and I will remain with 90 minus C over 2. And now from this, I want to apply sine and also apply cosine on both. Then I see what I will have. So when I apply sine on the left-hand side and also the right-hand side, open the bracket of the right-hand side only, I remain with something of that caliber. Of course, this is compound angle. Please learn how to open compound angles. Sine of into A plus B, sine of into A minus B. Very simple things. Just need to play with this algebra. Now, on pressing the calc, cos 90 is actually dying, and we shall not go for the barrier. And what we shall remain with is cos c over 2, because sine 90 has a brother called 1. What are you talking about? Check there. I will have cos c over 2 being equal to sine into a plus b over 2. Please, this is very important. I don't know what is very, very important compared to this, but one thing we should actually know is that this identity is very, very important. This one here. Very important. I'm telling you, very important. Next, another thing that we should remember, that when I apply cos on both sides of which identity, I'm applying it on this. I apply the sine, and this time round I'm applying a cos. Then I apply a cos, open the right hand side only. You will see someone opening even the left hand side. So let's open the right hand side. And you should press your calc, please. If you doubt the calc, and any calc that brings cos of 90 as 1, just throw that calculator, I'm telling you. So we shall remain with sine c over 2, because sine 90 has a brother who has a sister called 1. Check here. This is very important. Let me even put it on a house, in a house, because this one must be in the what? In the house. It is here. Very important. This one's here. They are very, very important. They are like that pocket money you have for this term too. Be careful with the pocket money, I'm telling you. Now, we also realize that when I try to expand sine into theta, this is compound angle. Sine into c plus c, it's like 2 theta. When I expand, I have 2 sine c cos c. Now, I want to get half angle from this double angle. Please, this tutorial is giving us very many things as far as half angles, double angles, compound angles, factor formulas, summation of angles in a triangle adding up to 180. Can you imagine? So here we are expanding, and I want to get half angles from there. I'm just going to have the angles. When I have angle on the left hand side, I remain with sine c. On the right hand side, those angles go to half. Now that I have got these perimeters, I just need to substitute what they do represent. So as you can see, sine of c over 2 is going to be represented by that. Cos of c over 2 is going to be represented by that. So we've got the team that is delegated to represent the sine c over 2 and cos c over 2. So in the next case, I will just represent them by that. Now I get back to my question, that instead of having sine c, I have got a brother, which is actually this one here. So the whole of this sine c will be dominated by 2 cos into a plus b over 2, sine into a plus b over 2. And that's what I'm going to do. That's what I'm going to do. As you can see. Don't you think now the game is done? I've got that identity from my side work, and I've played with very many things there. I've played with the addition of angles in a triangle. I've played with applying sine cos, and I've also played with the double angle for C, because I told you at first place I need to look for what will represent sine C, and I have got it. So from this level now, from this step, I can vividly see that I can actually factorize out what is common, and without doubt I can see that a 2 sine into a plus b and this 2 sine into a plus b, of course over 2, is common. So I'm just factorizing it out. I'm creating a bracket for it out. So on factorizing it out, ideally on factorizing it out in the next case, I've pulled it out. It is out. I'm telling you, it is very, very clear. And what I'm remaining with is again applying factor formula. Applying factor formula at this level here. So on applying factor formula, what I'll remain with is very simple, and we agreed on how to apply factor formula there. Please go through the tutorial very fast because my battery is also warning. And simplifying everything, students find it hard here to interpret this negative. Now I told you, if you press a cos of negative 60, press that one, it will give you the same answer as pressing cos of positive 6, and this is applicable on cos only, cos 60. So that one is very clear. So that's why at some point I'm going to ignore that negative, and in the next level I will have something of that caliber, and therefore my answer will be that. Thank you so much. Let's majestically move to the last question. Thank you so much. And the last question, of course. So number 4 wanted us to prove that tan A plus tan B plus tan C is equal to tan A, tan B, tan C. So still I'm going to apply factor formula on tan A plus tan B, but this one is going to come as a result of, basically not even that factor formula, but a result of, I try to use a result of what? Compound angle for tan into A plus B. So I had that something, some kind of side work. So when I open tan into A plus B, we all vividly know that it will be tan A plus tan B over 1 minus tan A tan B. And on simplifying it, I'm just cross multiplying, and I'm trying to look for substitution for tan A plus tan B. And when you cross multiply this fraction, you get to realize that you will have an equivalence of tan A plus tan B, which is tan into A plus B into 1 minus tan A tan B. So where I have tan A plus tan B, I will just put that. And also, since they are saying A, B, and C are angles of a triangle, when I add them up, I go to 180. Now, when I make C the subject, why do I need C? Because I want to get tan C. Tan C. So when I get tan C, by simplifying this, I get to realize that tan C will be equal to tan into 180 minus into A plus B. And then tan C, when I try to apply factor form, compound angle on tan into 180 minus into A plus B, I try to expand it patiently. You get to realize that for a tan of 180 minus, then it will be still minus, then down is a plus, as you can see. Now where I have tan C, I will have something of that caliber, but we can vividly see that if you press on the calc, keeping your calculator in degrees, you press tan of 180, it will go to a 0. So you get to realize that the whole denominator vanishes to actually 1, because it will be 1 plus tan of 180 tan, and 180 is a 0. 0 times something becomes a 0. So down I'll remain with 1. Even up I will remain with negative tan into A plus C, B. So basically that is what I will have for tan C. So I will carry the two perimeters. Tan C is equal to negative tan into A plus B. Substitute in the equation. But before that, I need to first substitute for tan A plus tan B. I need to substitute for tan A plus tan B. So we can realize that it is substitution is that. Then the next case I want to substitute for, okay, I can decide to substitute for tan into A plus B, which is equal to negative tan C. I open the bracket. On opening the bracket, very simple, I collect like terms and my tan C is disappearing. So eventually I remain with tan A, tan B, and tan C. Therefore, tan A plus tan B plus tan C is equal to tan A, tan B, tan C as required. This is your activity. Very simple numbers. Basically, we are still using the protocol. A, B, and C are angles of a triangle. Prove the following identities. Very simple. Here, the answers are always there as far as proofs or shows are concerned. You will always play with what you have. So my advice to all scholars taking principal mathematics is that, well, we are jungling with the scenarios here and there, but also you need to have the concept, have the content, learn how to prove these things, learn how to solve trigonometric identities, learn how to play with the content. Can you also prove that? And please allow me end there.